guys, it's Miss Sebastian. I just wanted to go over function representations here. Okay, that's 6.09. So we have a function here, and this is kind of like what you might see on USA Test Prep as well. Okay, so you've got your function as a graph, and you've got your function as a table. And it wants to know just to compare these. You'll see the word compare a lot on these. So you're going to have to look at these and figure out which one has a greater rate of change. Okay, the rate of change is your slope. Okay, so what I'm going to do is I am going to find our slope here. So I see a point here and I see a point here. Okay, this point, it's going to go rise 1, 2, and it's going to run 1. So this one, the slope is 2, and the y-intercept is 4. Okay, but our slope is at 2. This one we're changing by a constant rate of 1 over here, but we're going up 3 each time. So this one has a rate of change of 3. Okay, so there's our two equations. And I think I did. I may have been off just a little bit here. Okay, it may have only been rising 1. Let's change that to 1. Okay, so 1x plus 4. And this one has 3x plus 5. So I'm looking just at my slope. So this one has a slope of 3. This one has a slope of 1. So I'm looking down here, and I know that function 2 has a greater rate of change, meaning it's got a greater slope of 3. So function 2 here and here is a greater rate of change by a half, or what's the difference in these? 3 minus 1 does give me that 2. So I would choose that answer. This one couldn't be it because 3 minus 1 is not a half. Okay, let's look at another one. Okay, we've got Jessica and Raphael are saving money for concert tickets. Jessica has $20 and saves $10 per week. She came up with the following equation to figure out how much money she saves for any given week. Y equals 10x plus 20. Raphael has $40 and saves $6 per week, and he created a table to show how much he saves per week. Okay, after saving for a certain number of weeks, Jessica and Raphael will save the same amount of money. How much money will they have saved then? Okay, so we need to figure out when these two are equal. So what I would do is I would say, okay, I know that here's my y-intercept right here. This is 40 because that's when my x is 0. Every week he's going up $6. So I can write out y equals 6x plus 40. Now all I have to do is set these two equal to each other to find out when they will have the same amount of money. So I'm just going to take the 6x to this side. So I'm going to subtract 6x from both sides. Over here it cancels. And now I'm going to take the 20 to the left. $40 minus 20 is 20 equals 4x. Divide both sides by 4. and x equals 5. That means after 5 weeks, will they have saved the same amount of money? But that's not what our question was asking. It asked how much money will they have? Well, I can look and check right on Raphael's chart and say they will have saved $70. And I could test it in here. 10 times 5 gives me 50 plus 20 does give me that same $70. Okay, so let's look at this one. Alex and April are saving money to buy new phones. April has $100 and saves $25 per week. She made a graph to show what she saves in any given week. Alex has $125 and saves $20 per week, and he created a table. How many weeks will it take April and Alex to save the same amount of money, and how much money will they have? So I see that we've got a table here, and a table and a graph. And so what I would do is I would look and I would say, okay, I see at 2 weeks they'll have 150. Well, they're still a little bit apart here. So then I'm going to look at 4, just because I can see where the dots are pretty clearly here. 4 was 200. Well, they're getting real close here. So maybe at 5 weeks. So I'm just going to plug these in and see if it makes sense. Well, at 5 weeks, it looks like it'd be right at 225. That looks right, but let's write the equations for these just to make sure. Well, April has $100, so she has $100 just laying around and saves 25 per week. That per word right there means that it's going to multiply by your x. So I've got 25x plus 100, and then Alex has 125, okay, and saves $20 per week. Remember that per means multiply. So now I'm just going to set those equal. 25x plus 100 equals 20x plus 125. I'm going to subtract this 20x from both sides, and I end up with 5x plus 100 equals 125. Subtract 100 from both sides, and I'm left with 5x equals 25. Divide both sides by 5, and I am left with x equals 5. So we were right. 5 and $225. Now what you also could have done is if you suspected this 5, you could plug it in. 25 times 5 is 125 plus 100. That gives me the same number here. So you could do that by trial and error as well. Okay, so I hope this helps with 6.09 function representations.